Hello, my name is Ivan, and today we'll be solving this rational function. Our first step into solving this function is to try to find the asymptotes. And to find which asymptotes correspond to this rational function, we will be looking at the degree. So in this case, we have one bigger on top, which means no horizontal asymptote. And since it's one bigger on top, it means we will have a slant asymptote. And to find the equation of y equals mx plus b, we divide the numerator by the denominator using long division. And you only have to go as far as until you find your slope and your y-intercept, which in this case is to the second step. And so we found our equation here, which is y equals x minus 2. You don't have to solve the whole thing, just as long as you have your slope and your y-intercept, you can stop there. Next, we will be finding the vertical asymptotes, and to find those, we will equal our denominator to 0. We will factor the bottom and factor the top. Now, I know the factors to the top because I came up with this problem, but you're going to have to use Descartes' rule of signs and the rational theorem to come up with your answer. And once you do that, you look to cross anything else. In this case, we have x plus 2, which canceled out, and so we're left with x plus 1 and x minus 4 on top and x minus 1 on the bottom. So we only look at the bottom to find our equation. So x minus 1 equals 0. Our vertical asymptote would be at x equals 1. And to write our notation, which reads, as we go to the right of asymptote at 1, our graph goes, and as we go to the left of asymptote 1, our graph goes. We have to use our graphing calculator. So you input your information into your graphing calculator, and you hit graph, and you'll get something like this. At least you should. If you're not, make sure you fix your zoom to standard. Now from this, you look to the right of asymptote 1, and as you can tell, our graph is going down, and we look to the left of asymptote 1, and our graph is going up. So back to your limit notation, you fill that in. As we go to the right, it goes down, and as we go to the left, it goes up. So next, we take care of that x plus 2 we canceled out. That would be our whole. So x plus 2 equals 0. We have our x value at negative 2, and to find the y value, we plug negative 2 in for x, and at the end, to our simplified equation, make sure you use your simplified, and at the end you should get 2. So far we have our slant asymptote, our vertical asymptote, and our holes. Now we want to find our domain. Now the phrase we want to use when finding domain is diva, which means domain is vertical asymptotes and holes. In this case, our vertical asymptote was x equals 1, and our hole, we had a hole at negative 2. So those are our bad values. So our graph would go from negative infinity, would get to negative 2, it would break off, form a union, keep going from negative 2 to 1, break off, form a union, and keep going from 1 all the way to infinity. To find our y-intercepts, we want to use our simplified equation, multiply both sides by x minus 1, so we have y equals 0 and 0 equals only the numerator. And so we'd get y-intercepts at negative 1 and 4. So our points would read negative 1, 0, and 4, 0. Lastly, we want to find the y-intercept by plugging in 0 for x into our simplified equation. Make sure you use your simplified, because if you use the original one, you'll get a wrong value. So once you do that, you get a y-intercept at 4, so 0, 4. So now we have our graph, and on here you should have your slant asymptote, which is this line starting at negative 2 and going up 1, right 1, up 1, right 1. And you should have your vertical asymptote at x equals 1, which is marked by green. The points we found are in red, and this represents our 2 zeros, this represents our y-intercept, and this represents our holes. And the next thing you want to do in order to give your graph a more defined shape, you want to use your calculator's tracing function by plugging in values to the left of our vertical asymptote and to the right of our vertical asymptote. In this case, I chose the numbers negative 3, negative 4, and negative 5 to the left of 1, and 2, 3, and 5 to the right of 1. And once you use that, you simply hit trace on your calculator to find those values, and you would get your coordinates. So now we have a pretty good idea of what our graph is going to look like. We want to hug the asymptote and keep going in the direction of our vertical asymptote limit notation. And same thing to the right side. We want to hug the asymptote and keep going into our direction of our vertical asymptote, which we listed up here. So that is all. Thank you for watching, and I hope you understand.